We are all right. We are talking about practice with section 3.4. This is from the worksheet. We're talking about number 1D.
Hello, juniors.
Hello, juniors, and anybody else that's missing.
You suck.
We're going to start off by saying number 1 was giving us a position equation where it said x of t equals t cubed over 3 minus 2t squared plus 3t plus 1. Okay, you guys can, yay, this works. Beautiful. So for part D, it said at what times in the interval is x at a maximum or a minimum? Okay, I want you guys to think about what does a maximum or a minimum even mean?
When it hits the x-axis.
When what does?
The graph, the line, the velocity.
No, why does that mean?
Highest or lowest point, right? I know, so I'm agreeing with you. Highest or lowest point. Let me ask you this. If I throw, now granted we're going to talk vertical for just a second. If I throw a rock up in the air, when does it hit its maximum? Like we're saying the maximum distance.
When the velocity is 0.
When the velocity, how does velocity relate? It's the derivative. So you're saying when the derivative is 0, something will have a maximum value. Likewise, now granted, if we talk vertically again, if I throw something down into the water that happens to be very buoyant and it floats back to the surface, when did it hit its minimum?
With 0 velocity.
Once again, when the derivative is 0. Lauren?
But like an x cubed graph
Mm-hmm.
goes like this. So it's like, oh, it's
But-
infinitely small. It's not like
But right, we're talking about the derivative equaling 0. And we're only talking about time intervals from 0 to 9, so we do have cutoffs. Okay? So the first thing is, I'm not going to go too much into the details of the endpoints being maximum or minimums, because that's actually more so with next chapter, but I was really after the fact that you were going to take the derivative and set it equal to 0. You want to help me with that, or you got a question?
Question.
Okay, question, go.
So for these type of problems,
This
you
is
find,
David Kane talking right now.
For these type of problems, you find the velocity, and then that's what you carry over for everything. Basically, is always that velocity equation, not the original.
Well, it depends on what they're asking about. So you are going to use the velocity in this case because we know when the derivative equals 0, something is at a max or a min.
But for B and C also, how?
Oh, yes. Okay, so for part B, it said, is x increasing? So x is the position. Is the position increasing? Well, how do you know that? Something is increasing when it's... What is positive? The derivative is positive. So in order to know any of those, we have to come up with a v of t equation. And what is the v of t equation? Jacob, go ahead.
It would be, I think, so 3 times 1/3, that cancels it out, so it would be t squared.
Good.
Minus 4t plus 3.
Good. Okay. So this is, since this is our derivative of our position, part B right away we can know that x is increasing when the velocity is positive. Right? We had said a quantity is increasing in value if its derivative is positive. Does that make sense? Yes or no?
Yeah.
Okay. Who has any problem with that? Those of you that are like staring off into space, you either have a question or you're totally lost. So work with me. Lauren.
Are we on B or C?
I don't remember defining increasing as when the derivative equals.
Do you remember when we did related rates, though, and we were talking about the ladder, like sliding, and we said that that distance is increasing, so it should have a positive rate. But then as the top of the ladder slid down, so...
Okay, so it's kind of...
Right, so
it's
as
a positive rate.
Right, so as the top of that ladder slides down, this rate right here, dy dt or whatever, would be negative. Because y is decreasing. So we're keeping kind of that whole idea in mind. Okay? So this had nothing to do with that stuff up there. So this, again, this was for 1B. Jacob?
Well, the one thing I was confused about that, how when velocity is positive, it means that it's increasing. Like on number 2, I found that the value when you plugged it into the actual equation, like the original one that it gives you, was a positive value, but the velocity was negative. So how does that work?
Okay, what?
Because you're supposed to be using velocity and acceleration, not the regular equation velocity.
Oh, so the value for the cubic equation can be positive and the velocity can be negative?
Absolutely. That
Oh,
just
okay.
means you are, let's say, to the right of the to the right of the y-axis, but you're moving to the
I
left.
see, okay.
Right. Your position can be positive and a velocity is negative. Absolutely. Yep.
So then at what rate would that just be plugging for it? And then whatever.
Correct. That is the value of the derivative.
So that's being negative
So
five.
you would want to know what v of 4 is. Okay. Yeah. So for 1b, it said at what rate. That's the v value.
So
Okay.
3.
Questions? Anything else on number 1?
Would that be the same thing for C? Like it's C, but it's for acceleration, it's speeding up or something?
Right. So let's recap. How do you know if something?
Speeding up, something. They have to be the same thing as speed.
What is the same?
Acceleration and velocity are the same.
There we go. So speeding up, you have to have a positive v with a positive a, or you could have a negative v and a negative a. But they have to be the same sign. And then otherwise, the speed is decreasing, or you could say it's slowing down.
But then, so since acceleration ends up being 4, velocity ends up being -5, at what rate would it be slowing down? Would it be 4 because that's the acceleration, or would it be -5 because that's the velocity?
You would be talking speeding. If you're talking about the rate of speeding up, you're talking about the acceleration then.
Okay, so then it would end up being 4, which is the value.
Correct.
I
Okay.
just want to make sure.
Yeah, absolutely.
So I am have the same question.
Sure.
So for increasing and decreasing, you check the velocity.
For speed increasing, or for speed
No, just for
a position,
I think.
like moving up or moving down, or moving
No,
left or
like
moving
the-
right.
I don't know, whatever he is, what he is.
Increasing or decreasing? Is position increasing or decreasing?
Okay, so if the position is increasing, the velocity would have to be
So
positive.
you plug it into, you plug t equals 4 into
The velocity to find out if it's positive or negative, that's
Okay.
right.
And then speeding up and slowing down, that's deceleration.
Speeding up or slowing down is checking the signs of velocity and acceleration.
Right, so which rate would you use?
So then if you're talking about at what rate is the object speeding up or slowing down, you would use the velocity, or the acceleration value.
Okay.
Yep, the value of the acceleration,
But like for D, like back to the original, like what we were.
correct?
So why do they give you like 0 to 9? Like at what time is the interval 0 to 9?
You know what, don't worry about the ending values from 0 to 9. I'm not gonna give you something that,
Okay. 'Cause
Yeah.
that happened like later too. And
Yeah.
I was like, okay.
we'll talk more so about that with the next chapter coming up. This is a good segue into it. All right, I'm gonna pause here. Yes? Yo. Yes? All right, so